So electron affinity is kind of like the opposite of ionization energy. It's the energy change when a neutral atom gains an electron. But unlike ionization energy, electron affinity can be positive or negative. So we can describe it like this: the metal atom gaining an electron, or it could be a non-metal atom, I guess, gaining an electron. Now we have a negative ion, and there's this electron affinity. Usually, electron affinity is negative, which kind of makes sense. It's like, oh, you're giving me an electron? I'm gaining an electron, I'll give you some money, I'll give you some energy for that. Taking the electron away, no, you have to pay me. So it's kind of like a transaction, financial transaction. So most of these are negative, but some of them are positive. The alkaline earth metals and all the noble gases have positive electron affinities. So why would the noble gas not want to gain an electron? It's happy where it is. It's in that sweet spot. It's got its full valence shell, it's got 8 electrons, it's all good, and now you want to give me another electron and mess things up, right? There was room for 7 people in the minivan, and then along comes the 6th child, and now we can't all go in the same vehicle. Kind of like that. Not that, yeah, it did actually happen, but, so it's not going to like that. The alkaline earth metals, they really don't want to gain any electrons either, and so you really have to force it on them. Electron affinity trends, not very regular. It does decrease as you go down group 1, but the other groups don't show a trend where electron affinity generally becomes more negative across a period, but just very generally. And so those are the actual numbers, and they're just kind of, I don't even know why we talk about trends at all. So those are electron affinities. Metallic properties. So these are characteristics of metals, and the nonmetals are not this, right? Metals are malleable and ductile. Malleable means you can hammer it and bang it into a sheet. You know, you take a piece of metal and you hit it with a hammer and you dent it, right? If you take a non-metal and hit it with a hammer, it's probably going to break. It will shatter into pieces. Ductile means you can draw it into a wire. So metals are somewhat flexible in that way. Non-metals are not. They're brittle. Metals are shiny. Non-metals are not shiny. Metals conduct heat and electricity. Non-metals do not. Metals lose electrons in reactions. They become oxidized. Non-metals do the opposite. They gain electrons and are reduced. So we can talk about metallic character, which is how much like a metal is this element. Now you can have some metallic character without being a metal, right? We talk about masculine and feminine qualities. Well, can a female have masculine qualities or be more masculine than another female? Sure. And the same with males. And then, you've got everything mixed up in the middle as well, right? So there's not a hard and fast line here, but there's a trend for metallic character. And this is the one I actually find the easiest. So let's draw the stair-step line on here that divides the metals and the nonmetals. And the ones along here, their character is really muddled because they're not really nonmetals and they're not really metals either. They're just kind of in the middle, right? So if we look going down a row, say group 5, well, nitrogen is a nonmetal, and as we go down, we get closer and closer. Now we're getting into semi-metals, and then we get to a metal. So metallic character is increasing as we go down. Phosphorus is more metallic than nitrogen, even though they are both nonmetals. Going across, sodium, magnesium, aluminum, those are metals. Then we get to silicon, which is a semi-metal. And then phosphorus, sulfur, and chlorine, these are nonmetals. So as we're going across the period, metallic character decreases. They're actually going from being metals to being nonmetals, right? So chlorine is less metallic than phosphorus, even though they're both nonmetals. And if you think about sodium and aluminum, well, aluminum is less metallic in character than sodium. So metallic character decreases as we go across and increases as we go down. That's following the same trend as atomic size. Any questions? So again, there could be questions like this. Choose the more metallic element from each pair if possible. Let's just do one of these, boron or nitrogen. So we're going to find these two, boron and nitrogen. Well, we can tell from the color here that boron is a semi-metal, right? And nitrogen is a metal. So guess which one is more metallic? The semi-metal, right? Over here, these are metals. As we go across, they become less metallic. So boron is going to be the more metallic element. Make sense? That's a summary of periodic trends. May or may not be useful, the table, and that's the end.